Now, this video, I'm going to look at some more examples of working with your inverse functions. So the first example I want to look at is we have f of x equals a negative 2 over x. And we want to determine, does this function have an inverse function? Well, that means we need to first figure out, is this a one-to-one function? Well, the easiest way to do that is to go to your calculator. And if we graph this function, negative 2 divided by x, and I'm going to zoom standard, and we can see that here if we graph this function here, there is a split in the graph at the origin, and that's simply due to the fact that we have the x in the denominator, which cannot be equal to 0, so therefore it's undefined. And if we were to draw horizontal lines through the graph, is it going to ever cross more than once? So let's see if I copy this and post this over here to the notes. If we look at this, is this going to be a one-to-one function? Well, it looks like I can certainly draw horizontal lines anywhere, and it's only going to cross the graph one time. So it does certainly look like we are going to have a one-to-one function, which means this function does have an inverse. Now you may say that, well, if we get really close right here, as we get close to the x-axis on this side or over here, you're like, well, it looks like it's a horizontal line and it does cross it more than once. Well, that's where if you go to the calculator and we zoom in, so zoom number 2, and I want to move the cursor over here to the left where we have this line. And what you need to realize is this line is always getting closer and closer to the x-axis. So your fractions, it's getting very, very small in here, but it's always getting closer and closer. So if I zoom in right here on this location, notice here, this line, the graph, is getting closer and closer to the x-axis. And again, I know these look like straight lines here, but that's just because your calculator is not able to make a nice smooth curve. But as we get closer and closer, we can see that this graph is still going to get closer and closer to the x-axis. So therefore, when we draw our line, it's only going to cross the graph once. So if we want to go through the steps here to find the inverse function, it may be helpful if we replace the f of x with y. So really, this is the same as y equals a negative 2 over x. And now we're going to switch our x and y. So everywhere there's a y, we're going to make that an x. And everywhere there's an x, we're going to change our x values to y. And then our next step is to solve the equation for y. So in this case, we're going to multiply both sides of the equation by y so that we can get y off the denominator. So we would end up with yx equals negative 2, and that's because here the y's would cancel out. And then we want to divide by x to get rid of the x. So then we're left with y equals a negative 2 divided by x. So therefore here we have the inverse function is negative 2 over x. And this, if you notice, is the same as our original function. So what that means is when you plug into the one, you're going to get the other function that will take you back to your answer. So just realize that sometimes it is possible that your function and the inverse function may turn out to be identical. All right, next example. We have the function f of x equals 1 over x to the 4th. And we have the same question. I want to determine, does this function have an inverse? Well, in order to determine if this function has an inverse, we must determine, is it a one-to-one function? So if we go to the graph, we'll go to y equals, clear out the other graph, and we have 1 divided by x raised to the 4th power. If I go to zoom standard, we now have the graph here going up. And if we look at this, if I copy this over, is this going to pass the horizontal line test? Well, for this example, if we draw a horizontal line here, it's going to cross the graph here and here. So it's crossing the graph in two places. So therefore, this is not a one-to-one function. So therefore, there is no inverse. So in this case, we're not able to find the inverse because it is not one-to-one. Now, of course, we could restrict the domain. If we did that, then we could find the inverse like we did with an earlier example. But in this case here, this function then would not have an inverse. Okay, now we have f of x equals the square root of x minus 2. And we want to know, once again, does this function have an inverse? So if we go to the calculator, we can type in the square root of x minus 2, go to zoom standard, and of course we should know that what this is going to look like without the calculator. Knowing that we know the graph of our square root function, we should have been able to determine that the x minus 2 is going to shift our graph 2 units to the right, so we certainly do end up with this as our graph. And this will pass the horizontal line test, right? So therefore this is a one-to-one function. So if we go to find the inverse, we would have y equals the square root of x minus 2. So we're going to change our y to an x, and we're going to change the x to a y. And now we're going to solve for y. So to get rid of the square root, we have to square both sides. So we would have x squared equals y minus 2. The square and the square root is going to cancel out. So therefore, y is going to be equal to x squared plus 2. So therefore, the inverse function would be x squared plus 2. Now, one thing we have to be careful with, now we know the graph of x squared plus 2. Let's see, that's going to be what? Parabola. The plus 2 is going to move the parabola up 2 units. So we're going to go up 2 units, and we would have our parabola like this. Now, keep in mind, here's the line y equals x. Does this graph reflect the original function f that we have here? If this is the function f, if this is our inverse function, what's wrong here? Well, we have to realize this inverse function we found, x squared plus 2, we really need to eliminate this part of the graph. And how can we do that? Well, that means down here we must restrict our domain and say that our x values must be what? Greater than or equal to 0. Okay, and why do we have to do that? Well, if we notice the original function here, if we look at this graph, your x starts here at 2 and goes on, but notice here the y value is what? The range of this function here, let me actually write this down here. We have the original function here, the domain would be values of x that are greater than or equal to 2, and the range would be values of y. If we think of the range as being your y, the y has to be what? Greater than or equal to 0. Well, that means down here for the inverse function, if this is our range here, remember that becomes our domain. So down here we have the domain has to be greater than or equal to 0. Okay, and then our range is going to be this here, where the y has to be greater than or equal to 2, because if this is our graph here, the parabola doesn't go below 2. So there's the domain and range for your function and the inverse function. So sometimes you have to be careful here, particularly with the domain of the inverse function, because we have to limit that. Otherwise, the inverse function is not the entire parabola, it's only this right-hand side. Otherwise, it would not be an inverse function. All right, our next example, we have the function f of x equals x plus 3 squared. All right, now once again, we need to look at the graph of this, and we could go to the calculator, but I think we can figure this out by hand, hopefully. We know that we have x plus 3 squared. Well, we know we have a parabola. The plus 3 is on the inside, so remember that's going to shift your graph 3 units. Remember, it's on the inside, so it's going the opposite direction, so it's 3 units to the left. And if we think about the graph of this, we know it's going to be a parabola that like this that opens up. And here, I want us to find the inverse function. And the question is, how must we restrict the domain to do that? We did an example of this in a couple videos earlier. And how can we restrict the domain so that we will have an inverse? So in other words, we want to eliminate where this horizontal line crosses twice. Well, if we do the same thing we did before, we can eliminate the left side of the graph, and now this would pass the horizontal line test. So it looks like we could simply restrict the domain by saying that x has to be greater than or equal to a negative 3. And then I'm going to go ahead and indicate that if that's our domain, then the range, looking at the graph, should be obvious. Then it doesn't go below the x-axis, so that means our y value is greater than or equal to 0. So now we can actually find the inverse function. So if we restrict the domain to x is greater or equal to negative 3, that is therefore 1 to 1. So I'm going to say we have y equals x plus 3 squared. And then I'm going to replace the y with an x. And then the x turns into a y. And then we need to solve for y. So to get rid of the square, we're going to simply take the square root of both sides. So we have the square root of x equals y plus 3. The square and the square root cancels. And then we need to subtract 3. So y is equal to the square root of x minus 3. So we could actually write this then as the inverse function of x, the inverse function of f would be the square root of x minus 3. Well, the square root of x minus 3, well, we know the square root function looks like half of a parabola on its side, but then the minus 3 on the outside is going to move the graph down 3 units. And therefore, we're going to start here, and the graph's going to go something similar to this. And we know that if we looked at the line here, y equals x, that would be a reflection there of the graph. So here we have our inverse function and the graph of our original function. Now to finish this problem up, what is the domain for the inverse function? Well, our x values, notice, are what? X is always greater than or equal to 0. And the range of this inverse function, it never goes below negative 3, so that means y has to be greater than or equal to negative 3. So here's the inverse function, and here's the domain and range. And hopefully you're noticing that here for the domain, that's kind of the range here. And where we have the range of the inverse function, y is greater than or equal to negative 3, then that gives us the domain up here where x is greater than or equal to 3. And again, that goes to the idea that we're switching the domain and range from the function to its inverse function. All right, our next examples will be slightly different. We're going to be given two functions, f of x equals 1/8 x minus 3, and g of x is equal to x cubed. And we want to find g inverse of f inverse of a negative 3. Now, I'm going to rewrite this. I like to write it this way. We want to find g inverse of f inverse of negative 3. To me, this just looks a little bit better. So if we want to find the inverse of a negative 3 and then we want to find g inverse of that answer, then that means up here we need to find the inverse functions first. So if we look at the original function here, f of x, we need to find the inverse of f. So if we're going to find the inverse of f, then that means here we're going to replace f of x, which is our y, so that's going to become x equals 1/8 y minus 3, and then we have to solve the equation for y, so I'm going to add 3 over, so we get x plus 3 equals 1/8 y, and then we're going to multiply both sides of the equation by 8, so that we can cancel out the 1/8. So then we were left with 8x plus 8 times 3 is 24. And the 8 and the 1/8 is going to cancel, so we're left with y. So here we have the inverse function is 8x plus 24. All right, next we need to find the inverse of g. So we're going to do the same thing. Again, g of x is our y, so we're going to make that x equals y cubed. And now in order to solve for y, we need to take the cube root of both sides. And in doing so, we have the cube root of x is equal to y. So that means the inverse of g is simply the cube root of x. So now when we want to find here g inverse of f inverse of negative 3, that means we want to find f inverse of negative 3. So f inverse of negative 3, we simply plug 3 in, or negative 3 rather, in for x. And we would end up with negative 24 plus 24, which is equal to 0. So that means next we want to find over here g inverse of f inverse of negative 3. Well, we just found the f inverse of negative 3 to be equal to 0. So now we're going to plug 0 into g inverse. So g inverse of 0, that means we're going to plug 0 in for the x, and we get the cube root of 0, which turns out to be 0. So the answer is 0. G inverse of f inverse of negative 3 is equal to 0. So in order to find g inverse of f inverse of negative 3, we had to find the inverse of f, we had to find the inverse of g, and then do the calculations. Now let's look at another example similar to this, where we have f of x equals x plus 4, and g of x equals 2x minus 5. And here they want us to find g of f inverse. So notice this is slightly different. And again, I would prefer to write this as finding g of f of x, and we want to find the inverse of this whole thing. So what that means is first we need to find g of f of x. So that means we're going to take function f, and plug that into function g. So we would end up with 2 times x, so that's really 2 times x plus 4 minus 5. So then that means g of f of x is going to be equal to 2x plus 8, distribute the 2, minus 5. So we would have 2x plus 8 minus 5. So 8 minus 5 is 3. So we have 2x plus 3. So this here is our g of f of x. So now what do we need to find? Well, we need to find the inverse of this. So really, this is our y. So really, this is simply y equals 2x plus 3. And remember, what's our order here? We're going to replace the y with x, replace the x with a y, and then we simply solve the equation for y. So we subtract 3. So x minus 3 equals 2y. And then we have to divide everything by 2. So we end up with y equals, and I guess we could just divide this whole thing by 2 to make it easier. Since nothing's going to cancel out, we could think of it this way. And we would simply have x minus 3 divided by 2. So therefore, this is going to be your g of f, the inverse here. So here, this step, we actually had to find the composite function first. We need to find g of f of x, and then once we found g of f of x, then we could find the inverse function. So notice how that is slightly different than what we did up here in the previous example, where we actually had to find the inverse of each function first and then perform the operations.